To, co gadaliśmy na spotkaniu, że one a little bit about caching in SBT2, and I'm working as a Scala developer at Virtus Lab. Before I will jump to the main presentation, I prepared 2 slides with quick introduction. The first thing is about SBT. This is one of the most popular build tools for creating Scala projects. Its main 2 components that I will use today are settings and tasks. Settings are like static configurations in a project, like for example Scala version or project version. But tasks are more like jobs that we can perform on demand, such as compilation, tests, or creating some jars. And today I will focus on tasks because tasks are things that can be cached in SBT. Also in SBT we have a bunch of built-in tasks like compilation or tests, but also we can create our own task. And I will do this today. The second introduction is about caching. In simple terms, this is a mechanism for remembering the performed task to avoid repeating them in the future. And this is the most valuable for long-running tasks because when we cache the results, we can just read the task results on subsequent runs without executing the entire task logic, which can significantly speed up development workflows. And agenda for today, at the beginning, I would like to show how caching in SBT1 works. This will demonstrate a slightly lower level overview of caching, and it will show its limitation in SBT1. Later, I will introduce caching in SBT2, cache structure, caching files, and I hope I will be able to show some practical examples at the end. But maybe first I should answer the question why at all I decided to create a presentation about caching in SBT2. So the main reason is that in SBT2, each task has caching enabled by default, and it's likely that sooner or later, while working with SBT, you will encounter this, no matter if you are a maintainer of SBT configurations or just a user. So yeah, let's look at caching in SBT1. Here I have pretty simple project in SBT1 with one custom task built. Do you see it? Is the font okay? I don't like this. Maybe I will zoom more.
Just write presentation mode.
Yeah, but I don't. I will zoom.
You can increase the font size.
Yeah. Like this? Yeah. OK. So here I have one custom task, built metadata in this project. And each task in SBT must have a key, and this is task key. It contains information what is a task return type. And in this case, this is build info. This is a custom type that I created in this project. And besides the key, each task must have an implementation, and we have this here. And right now, this task only creates a build info object with the current project version. Version is an SBT settings that is already built in SBT. So the simplest way to see how caching works in SBT1 is to just create a cached task. So let's do it. My idea is to create a cached version of build metadata task because right now it's not cached. I have some notes for this. Yeah. To create a cached task in SBT1, we need to do three things. The first thing is to decide what input should invalidate this task cache. This is a very important step because once the task result is saved in the cache, it cannot be used forever. The general rule is that the cache task result is only valid as long as task's inputs don't change. And in this task, this input that should invalidate the task cache is the current project version. Basically this thing. This is the only dependency and input we have in this task, so it wasn't hard to choose. And the second step is to get information whether this input has changed since the last task ran. We will use it in the next step and the last step. And the last step is to get the previous task result from the cache and decide whether to use it or recompute the new value for this task. So let's implement. We already did the first step, so let's do the second one. And in SBT1, we need to do a special caching API to test the input. Its method input changed from the tracked object. And it returns a function that we need to call with the input. So our input is the current project version. And yeah, here we have a variable isChange that says whether this input has changed since the last task run. We will use it in a moment, but for now I will print this, so we will see this variable when the task runs. Okay. And I can now implement the last step. So get the previous task result. In SBT1, the simplest way to get the previous task result is through previous extension method, which we can use on a task. And it returns option of task return type because cache might or might not be. Okay, and unfortunately we have a small problem here about missing JSON format for build info implementation. This is because previous method wants to cache the result from the build metadata task. So it wants to save to disk build info object, and it doesn't know how to serialize it because this is our custom type that we created in this project. So we need to implement this JSON format. And yeah, JSON format is a type that gives information how to serialize custom types. So we need to implement this. I used the project format utility method from the library, but JSON format can be created in many ways depending on the context and complexity of your type. And the problem is gone, so I can do core caching logic. I will do pattern match on a preview. And if there is something in the cache and the project version hasn't changed since the last task run, then it's okay to use the value from the cache because it should be up to date and it should be what we want. But unfortunately, in any other case, so if the cache is empty or the project version has changed, we need to create new build info. Okay, I think that right now the core caching logic is done, but I would like to add one more thing to this. Because right now, no matter if the value is taken from the cache or it's, let's say, recalculated and new build info is created, we wouldn't be able to see any difference in the SBT output because both things happen instantly. To make caching visible, I will add a 2 seconds delay to this branch, so we will be able to see a difference in SBT output. I added a create method that sleeps for 2 seconds and then creates build info, and I will use it here. And right now, if the value is taken from the cache, the task will take 0 seconds to execute. But if the value is recreated and create method is triggered, then the task will take 2 seconds. And we will see this in the SBT output because it always displays task total time. So let's try this now. Okay, we see the first input changed true. This is because the task ran for the first time, and the task took 2 seconds. It is expected because the cache was empty. And on the second run, the response is from the cache. We see this from total time 0. So we have caching in this task. Maybe let's test it and change the project version, because this should invalidate the cache. Right now, we don't want build info from the cache because it's with version 0.11, and we want version 0.10. Yeah, and the cache was invalidated because right now the create method was triggered and the task took 2 seconds. And on the second run, again from the cache. Okay, now I would like to run a clean task. I guess for people who work with SBT, this is a well-known task, but for those who don't, the clean task should remove files produced by the build and also some other things. So let's run this, and again the cache task. And right now something wrong happened, because even though the last response was from the cache, we see this here, and I didn't change the project version, right now the response is not from the cache. This is because cache in SBT1 is stored inside the project, inside the target directory, and running clean task, or maybe even removing the entire target directory, which we know sometimes can happen, cause the entire cache to be deleted. This is also a drawback when we have multiple copies of the same repository on a single machine, because they cannot share the cache because the cache is stored inside each project. Okay, I think that's everything for, yeah. And it's finally time to look at caching in SBT2. I have basically the same example as we had in the SBT1 project. I'm using release candidate 9, which is, I think, the newest SBT2 release candidate. And I have the build metadata task that creates build info. So maybe let's test it and try to run this task in SBT2. And unfortunately, SBT cannot even start. We have exception about missing JSON format, and we can disable the caching or implement this. And maybe someone still remembers that we had exactly the same problem with JSON format in the SBT1 project. And the root cause is the same here, because as I said before, each task in SBT2 has caching enabled by default, and SBT also wants to cache the result from build metadata task, and it doesn't know how to serialize build info. So we need to add this JSON format to the project. And I have this here. I just need to uncomment the code. I also have here this create method, and I will use it in a task. Let's try again. Okay, so let's run the task. Okay, and the task took 2 seconds because this was the first task run. But here we have a first new thing in the SBT2, which is a cache hit rate. It says for how many tasks the results were taken from the cache. I said tasks, not task, because each task in SBT may depend on multiple other tasks, and all of them are included in a cache hit rate. But on the second run, it's from the cache. We know this from the task time and from the cache hit rate. So basically everything what we had to do in the SBT1 project to have a cache task is no longer needed in SBT2, because we have caching almost out of the box. So let's do the same as in SBT1 project and run clean task. And I will even go one step further and remove the entire target directory and rerun the task. And now it works differently than in SBT1, because after running the clean task, the response is still from the cache. This is because in SBT2, cache is stored in a global directory on machine, not inside the project. And so running the clean task doesn't remove the cache. As I said, the cache is stored in a global directory, and on macOS it's here. And it looks like this. This directory is not directly related to caching. It's something new in release candidate 9, and it's something about registered SBT servers, but I don't know much about this directory. But these directories are about caching. I guess for people who work with Bazel, this is a well-known structure, because from what I know, it comes from Bazel. And AC directory stands for action cache, and it stores the information about performed task, including where the results are saved. And CAC stands for content addressable storage, and it stores the actual serialized task results. I would like to show what files in these directories look, because I think it's interesting, and also how they are connected, because they are. Using our build metadata task. But before this, I will clean the entire SBT local cache, because right now it contains multiple files and it will be really hard to navigate between them and show something. For this, I will use clean full task. I think it's something new also in SBT 2, and it removes SBT local caches. Now the cache is empty, so we can run the task again. And it should produce one file in the action cache with information about performed task, and one file in the content addressable storage. Oh, I need to go there. Yeah. Let's first check action cache. It contains one file, and this file looks like this. And here we have a very important information. Where is the task result? And it's here. Out is an output directory inside the project. The name of this folder is the hash that was calculated for a task. And in this JSON, we should have task result. The hash that follows it, this is the content hash of the file with a task result. I will say a little bit later about files content hashes, so let's skip this for now and focus on this path. As I said, out is an output directory inside the project, so let's go there and check what we have. Yeah, we have one directory with a hash, and it contains something. But this something is just a symlink to the content addressable storage, and there we should have serialized task result. Let's check. And we have. The last response from build metadata was build info with version 0.11, and in the cache we have version 0.11. So we managed to find out serialized task result in the cache. We see this in this JSON format because this is how I implemented the serialization, but of course it can be different. Okay. Maybe I should clarify why we have this symlink in the project, because I think it might not be obvious. So in a scenario without this symlink, after generating the task hash, SBT would need to go to the action cache, read this file from action cache, read parse, and from this file navigate to the content addressable storage and read the task result. So SBT would need to read and parse action cache and read and parse content addressable storage. But with this symlink, after generating the task hash, SBT using this symlink can jump directly to the content addressable storage, skipping reading the action cache, which can, in theory, speed up the cache lookup. But to be honest with you, I don't know how much improvement it may bring, and I didn't find this. Also, a small note here. From what I know, this mechanism with symlinks in the project directory does not apply for all use cases, and also it has its own limitations.
By chance, do you know whether it would work on Windows machine too?
From what I know, on Windows, SBT will copy a file, and you should get a warning that maybe enable developer mode or something like this to have caching, to have symlinks. Sorry. Okay. Yeah, that's everything. And working with files. Working with files is an interesting problem in caching, because files might be, for example, included when generating task hashes, and we may want changes in those files to invalidate the cache. So we need a stable and reliable way to identify files content without, of course, storing each file's content in the cache and comparing the entire content. We cannot use for this purpose just file paths because they don't say anything about file content. Using files metadata is also not ideal because it could cause the cache to grow too large, and I will show this later. So SBT introduced a new file type. It's hash virtual file ref that represents a file using its path, but also its content hash and file source. And here it works as a file identifier in caching, unique proof of file. And we see this here. This is how hashed virtual file ref looks, or maybe to be more precise, this is how it's serialized. We have a file path, and it's followed by file content hash, so the hash generated from file content, and file size. And I would like to show what benefits it may bring in SBT2 using some example, and I decided to use a package src task for this. This is a task that is already built in SBT, and its goal is to create a source jar in a project. First, I will show how it works in a SBT1. I will use the same project we had before. I will start SBT in a debug mode now because it will show detailed information when the source jar is created, and it might be helpful. Okay, and we see all the logs about creating the source jar, what files were included, and where the final jar is. And on the second run, we just see that the current jar is up to date, and we are in SBT1. This is because even in SBT1, inside package src task, there is caching, some caching. Now, I would like to change the source files metadata. I will do this manually for simplicity, but files metadata may, for example, change when we switch Git branches. We see that metadata has changed, and let's run the task again. And unfortunately, after changing source files metadata, the cache was invalidated and the jar was created again, even though the sources didn't change. This is because task package src in SBT1 depends on source files metadata, and when they change, the cache is invalidated. Let's check the same in SBT2. This is the same project we had before. It's not new. And it looks similar as in SBT1. We see all the logs about creating the jar. And on the second run, it's from the cache, also the same as in SBT1. Let's change the source file metadata. And now it works differently than in SBT1, because after changing source files metadata, the jar wasn't created again. This is because the caching and task package src in SBT2 relies on source files content hashes, this new hashed virtual file ref, not the metadata. And as long as files content doesn't change, the cache is not invalidated. And this is a nice improvement because it prevents the cache from growing too large, as it could happen if we relied on source files metadata, as we saw in SBT1, where for the same sources, the jar was created again. I would like to show one more thing with a package src task, because as we saw, the goal of this task is to create a jar and have it in some specific location in the project, like this location. So let's imagine a remote caching is configured and task package src runs on some another external machine for the same state of the code base. We would expect after running this task to have this jar in the project on this another external machine. So the problem is that this jar must be somehow materialized there from cache. And SBT has a special mechanism for this, in which tasks may declare files they create, and then those files are saved in the cache and might be recreated from cache if needed. And task package SRC uses this task, and I would like to show this. I won't show this with any external machine because I don't have even a remote cache configured right now, but I can simulate this with a fresh clone of the project, because if right now for this project the response is from the cache, we would expect to have the same in the fresh project. I will push whatever I have. I have nothing, so maybe I will just do the fresh clone. I will stop the IntelliJ import because we don't need the project to be imported right now. And I will again start the SBT in a debug mode. Okay, and we see that right now there is no source jar in the project. It should be somewhere here. So let's run package SRC task here. Yeah, and we see no logs about creating new jar, so it was taken from the cache. Let's see whether this jar is present in a project. Yeah, it is right now. It's here, so it was materialized from cache in this new project. What's interesting here is that this jar is just also a symlink to the content addressable storage, and there the actual jar is saved. Okay. So a quick recap about caching in SBT2. Cache is enabled by default, and we don't need to manually implement caching, maybe except for some things for serialization. The cache store is configured outside of the project, and it's remote ready, as its structure should already work well when the remote caching is configured. And we have this new hashed virtual file ref, which should simplify and improve working with files in caching. That's it. Thank you. Are there any questions?
So is there any way in SBT 2.0 to actually implement the caching mechanism manually like in SBT 1.0, or is there only automatic mode?
I think the API is still available, but you don't need this, and you shouldn't need this.
Just want to share some registered projects for those who didn't take classes.
Could you repeat?
Would you plan to share these two projects somewhere for those who didn't take classes?
Yeah, I can, of course. So, okay.
About serialization, so it looks like at any point at which I want to define a task, by default it's cached, and if I use some custom type, all the time I have to define JSON serialization, right?
Yes, but for custom types, for standard types like strings, ints, path, etc., there are already implement serializers, and you don't need to care about this.
Why can't I get default serialization for all case classes, for instance? Because like usually when you define custom type, it would be like case class, which consists of things which for which you already have serialization. So why can't I get some, I don't know, just like usually people don't want to get bothered.
So something like. For example, if you have a case class and you already have JSON formats for each type in this case class, for example, you can convert your case class to some. I found in the library there are a list type that can store multiple times, and if you convert your type to this list, then and you have serializers for or types in your class, then this list in the library should automatically derive the final JSON format. But you still need to convert your class to this list type.
Well, it sounds like a problem. Well, first of all, it's not a good developer experience, I guess. But overall, why can't we have like default serialization? Because like I was writing Scala for I don't know 13 years, and my mind is corrupted with all that stuff. So also when I like see like custom type, okay, I need to define serialization. But like in some languages or like ecosystems, people get that by default or like with very little effort. Why can't we have it in SBT? I guess SBT is like when you write SBT, it's not like normal Scala, it's magic Scala. Why can't be more magic?
Maybe, yeah, I agree with you that some auto derivation of JSON format could be useful.
That sounds like a feature request for SBT repository.
Yeah.
It's also possible to bytecode it. Right?
So maybe JSON method could be implemented there, and we would have this at least partially implemented.
I think it's JSON use, the thing that we used before in SBT. It should be possible, but
I mean, JSON method is Scala. We do this one, so little effort and type setting.
it should be possible. Like feature request in SBT, I think it was on purpose, but you can discuss it with Eugene if he's available.
Okay.
I think in general, this is not a unique problem with SBT. All the Scala JSON formatters do this, and it's because deriving a JSON formatter can result in a bunch of code being generated, and if you do it every single call side, we realize something can become very expensive. So I know all the JSON formatters started begin automatically by default, like Circe, Utica, whatever, and all of them stopped doing it after a few years because it causes a very unpredictably slow compile time. You stop the code repeatedly throughout the code base.
Like I guess in every single task that would be
Yeah, every single task returns a list of generated whole list that formatter with taking parameters.
Okay, about the saved things in the cache. So you showed us like version 1.0 saved in the cache as a JSON, but what if the JSON serialization changes by some, I don't know, other changes while the cache is still there?
It's. To be honest, I don't know. It's interesting thing. Maybe some runtime error will be thrown because if you have something in the cache and SBT couldn't deserialize it because you changed your serializer, then maybe some runtime error will be. But to be honest, I haven't checked this.
Maybe it will not just find the cache.
I think it will find the cache, but it might have problem with deserializing this.
Yeah, but then it would just try again, like not use the cache value.
Maybe, or there will be error.
I mean, there could be a case when your deserialization will succeed just because you use like less fields or whatever. So interesting problem.
Yeah, I haven't checked this yet. Okay, so.
Okay, thank you very much, Alexandra. Now it's unfortunately time to make some human connections, so please try the name tags to make it easier. Out there, got some snacks and very cool swag from JetBrains behind me. We have at least half an hour, maybe even more.
Hello, hello, 1, 2, 3. Can you hear me? Oh, hello, hello, 1, 2, 3, 4. Testing, testing, 1, 2, 3, 4. Okay. Presentation is about one of the new features at the Mill Build tool called declarative Scala builds. So this is quite a departure from how mill used to be, and we'll talk about how mill was before, how this new feature kind of fits into the mill build tool as a framework, and why you'd use each one and what benefits or trade-offs each version provides. So we'll talk about mill, we'll talk about the downsides of mill's traditional programmable build style. We'll show off mill's new declarative builds, touch on mill's new scripting features, and talk about how we can integrate declarative and programmable builds in the same project. So you're not forced to choose between one or the other, which is often the case with other build tools on the market out there. So about myself, I've been working on open source projects since about 2012. Mill, which is one of the topic of this presentation, MNIT REPL, serialization libraries, file system libraries. My background is in developer tools, so all sorts of IDEs or build systems or CI systems and so on. First, let me quickly go over the mill build tool. Who here has used mill? So a few of you. So for those of you who haven't, mill is an open source build tool. It supports all the JVM languages. So even if you're not writing Scala day to day, if you're writing Kotlin or Java or even Android, you can try using mill for your projects. It aims to be faster, easier, than Maven, Gradle, or SBT. One of the headline numbers is about 3 to 6x faster than Maven or Gradle to compile the same code using the same dependencies, just because it has much less overhead than the traditional JVM build tools often have. The build files look like this on the right. You see it's a Scala syntax. I have an object which extends Scala module, methods to define the Scala version, Maven dependency list, a nested test submodule which has its own Maven dependency list and test framework config. From this I can do /mill, compile, run, assembly, test, compile, all the standard build tool things using this Scala DSL and this command line syntax. So if I go over here, I can show you, this is my programmatic Scala build in mill. I can run /mill foo.test, for example, to test this code. So one advantage of mill's programmable builds is that because it's written in Scala, the build file is written in Scala, you can easily put logic into it. For example, on the right, you can see here we have a foo module, which has a Scala version, but also has a custom line count task that reads the all source files, sums them up, counts a line, sums them up, overrides our resources, generates a new line count txt file with the line count number, and appends it to our resource path. So this resource line count txt will be available at runtime. So this is kind of a synthetic example. It's not, no one actually wants to count their lines and put in a resource files, but shows you how easy it is to customize your mill build with custom build logic, just using method definitions, method calls, overrides, and supers. So these are all things you all already know how to use. You've been using it for 10, 20 years. Even before you learn Scala, you've been using it in Java or Python or JavaScript. And it works the same way in mill. You just define methods that call other methods, override methods and call super, and that's how you extend your mill build pipeline to do additional things in addition to what they were doing before. And once you have this object-oriented build config, you get the parallelism, caching, all the other good stuff completely for free. For example, just by defining the line count method, I can call line count from the command line, and it becomes a command line subcommand I can use to run my mill build. So apart from just having an object, singleton object that defines methods and inherits traits, you can define traits yourself. For example, here I'm defining a line count Scala module that has all the same stuff we just saw earlier, but because it's a trait rather than a singleton object, foo, I can now inherit it twice in different singleton objects, in this case foo and bar, and I can run it from the command line, foo.linecount, bar.linecount, which is a foo.linecount you expect to see in the code in Scala. And these traits, in addition to being used locally to standardize or reduce duplication within your build system, can also be published in Maven Central to serve as third-party dependencies. So you just push up in Maven Central using mill standard publishing workflow, and anyone else can depend on it, inherit it in their own modules, and they too can count the number of lines in their code base and put it in a resource file for use at runtime. So that's the long and short of programmable builds. So now we're going to talk about the downsides. Why is this not good? And I think the basic problem here is that there are many projects out there that do not have custom build logic. Probably most projects out there are small and do not have custom build logic. And so they do not benefit from the flexibility of all the stuff I showed you earlier. but they do suffer from the boilerplate and complexity that having a build file written in Scala adds. So this is Scala, and Scala is quite a concise language, much more concise than Python or Go or whatnot, or Java. But if you actually look at what people care about, they don't care about these packages or imports or objects or defs or these string interpolator prefix things. All that's just boilerplate that I need to put in to make the Scala compile. And what they actually care about is they care, this is a Scala module, has a Scala version of here, has Maven depths here, has a test submodule, which is a Scala test, which has Maven depths and test framework. All the other Scala stuff you see on the left and on the top is basically pure boilerplate. It's good if you want to use a Scala language to extend your build, because that lets you write your own custom methods and call other methods and put custom logic. But in the common case where your project is small and you just want the defaults, all of this is pure boilerplate that just gets in the way. So that's where the idea of declarative mill builds came from. So the idea is, well, if all of this is pure boilerplate, what if we just have a config language that doesn't have all this boilerplate? It might not be quite Scala, but it has all the same information, just in a much more concise and declarative format, as long as you're willing to give up the flexibility that Scala affords us. So declarative mill builds basically say, I'm going to take my Scala code with all of its boilerplate, I'm going to strip away the boilerplate, and I'm going to take this and put into a proper config language that has the exact same stuff, in this case in YAML. And it would look even more similar if I use a new Scala : syntax for white space delimiting on the right. But you can basically see that this contains the exact same information in the YAML format as a Scala file has on the right, but without all the kind of annoying boilerplate that's only necessary to make my Scala code compile. I have my extend Scala module, I have my Scala version 3.7.2, I have my Maven depths list with Scala tags and main args, I have my test submodule, I don't have all the object package, imports, defs, seek, I don't have all the quoting and string interpolator prefixes. I just have the pure data in my build. And I can show it to you here. So over here, if I go to my other folder, this here is my declarative Scala build file. And it works exactly the same as my programmable build file earlier. Sorry, let's just do foo.compile demo. Yeah, I'll show it. But it basically works the same as my programmable build file earlier, except without all the kind of annoying boilerplate that my Scala code forces upon me. So I'm just going to fix this one moment. So I think this should probably be foo.scala test, and then it should work. Blah, 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 compile, run, test. Okay, now it works. I got the typo in there. So if I put this side by side, you'll see that over here is my Scala build file. Over on the right, I'm going to show the application code and the test code. I'm just going to flip them around so it matches the same order. So this matches this, more or less, and this matches this. And again, you lose a bunch of flexibility, but for projects which are small, you often don't need the flexibility, and just having a tiny little config file that's literally like 5 lines of code makes it really easy for you to just configure your project and add a new submodule that does whatever you need without having to worry about having my package statements lined up and my imports set up correctly and my Scala code formatted properly in Scala format and all the other things that your Scala builds require of you. So mill declarative builds support most of everything that the mill build tool supports. So this is not like a new build tool that has its own feature set that's different from the old feature set and you need to remember what supports what. Basically everything that mill supports can be done in declarative builds. You can see in this example here, I'm defining I have multiple inheritance. I can extend both Java module and publish module. I have Maven depths, I have custom repositories, main class, JVM version settings. I can append sources or resources using YAML tags. I can set my Java C options, fork args, my fork end dictionary. I can have my publish to Maven central config, all of my POM settings and so on. All of that works in your declarative builds exactly the same as in your programmable builds. And if you actually look at this, this can be written in programmable syntax and it's just kind of more noisy and annoying to do so. So you see this on the left, this is your programmable Scala build.mil file. This on the right is a YAML. It has exactly the same information, like basically one for one. Your strings become strings, your sequences become sequences, your YAML or JSON maps become Scala maps, or they become case classes in some cases where the keys and value types are known. But generally it means exactly the same thing. And so almost everything that you can do in your traditional mil build, whether it's publishing or packaging ground native artifacts or running Scala format or building an Android app or Spring Boot applications, all that can be done in declarative mil builds too, just with a bit less boilerplate, but also a bit less flexibility. So basically all this stuff I mentioned works the same way in declarative and programmable builds. It's really the same build tool, just a different surface syntax on the top. And you may ask, like, how does this syntax on the right map to a syntax on the left? Like, how do I know what, for example, that my Scala map maps to a JSON map here? And what you can do is you can just go to your any mil project. I can just do mil show, like let's say Maven deps, or foo.maven deps. And you see that mil already has a JSON structure underneath it. Every mil task serializes to JSON, whether it's a JSON list, whether it's a JSON string, whether it's a, let's say, like JSON dictionary. So everything you can do in mil already has a JSON format. It's a nice JSON hierarchy. Your tasks and the tasks within the objects, the module objects form a tree in mil, and the tasks form the leaves of the tree, and every task itself is a JSON tree. So your mil build is already basically one big, large JSON structure. And yes, there's Scala code to compute it in the previous case, where you have this Scala code that has this dependency graph and everything. But after you've done the computation, it becomes this JSON structure, and that is exactly the same JSON structure that you inspect from the command line. And that's exactly the same JSON structure that mil lets you write in your build.mil.yaml files. So again, there's no new like build tool here with its own schema and its own logic and its own like standards and conventions. It's the exact same data structure, just represented in two different ways. Traditionally using Scala, but now we can also use YAML. So the one thing that you cannot do in your programmable mil builds, or in your declarative mil builds, is custom build logic, like what you see here, we demonstrated earlier. So YAML does not have a way to run map os.readlines.size, super override, all that stuff. So your declarative mil builds are basically limited to simple JSON data structures. And that's okay for most things. For some cases, you do need the flexibility, and we can cover how to do that later. So one last thing I'm going to touch on before we go into talk more about declarative builds is mil Scala scripts. So the idea for mil Scala scripts is that we already have this YAML structure. It already lets us configure our build in 101 different ways. Why don't we just put the YAML structure in a comment-able file, and we have a scripting environment that we can have a Scala script or even a JavaScript or a Kotlin script, and just add whatever dependencies we want on top. And we get the whole scripting tool chain completely for free. Not quite for free, and we have to parse the YAML comment and feed into the mil, it's like build.mil.yaml or package.mil.yaml infrastructure. But basically, with not much effort, we can take mil's declarative builds and turn into a very Scala CLI-like scripting environment without having to implement like 100,000 lines of Scala CLI, however much code is in that code base. It's like a tiny amount of code to now we can run mil HTML scraper.scala, you pass in arguments, and it runs using these third-party libraries, and you can pass in things like JVM version, create assemblies. You get the full functionality of a build tool in your scripts. You get the good performance of the mil build tool in your scripts because mil is quite heavily optimized already. And you can use it for all sorts of things that you may otherwise be using Python or JavaScript or Bash or Ruby for. So I'm going to talk more about scripts in my talk at Scala on Friday. But this is just an interesting usage of mil's declarative builds to let mil go into a completely different domain where it previously wasn't really involved in. And I guess one interesting thing is, yeah, even your scripts can be built into native assemblies. You just set the JVM version to native image to Graal VM, and can use native image to build a Graal native image out of a small script and run it yourself later. So it's quite handy as a scripting environment and quite powerful. So the last part of this talk, I'm going to talk about integrating declarative and programmable builds. So this has often been a pain point in traditional build tools. Like either use Maven, which is declarative, or use Gradle, which is programmable. And either you hate the other guy or you're jealous of the other guy who's using the other build. But either way, there's no way to square it. You have to really make a choice, one or the other. And if you make a choice, you're stuck for the next 5 years because porting between build tools is very difficult. So Mill does something different here. In that Mill lets you quite easily integrate your declarative and programmable builds within the same code base. So you're not forced to make a choice, and you can just use whichever one makes sense at that point in time for that submodule, and easily change back and forth later if necessary. For example, over here, I have a small example where I have the root module is a programmable build.mil file with the Scala syntax, but the test submodule is a declarative package.mil.yaml file using the declarative YAML syntax. And everything we saw earlier with the full programmable or the full declarative styles works here as well. You can compile, run assembly, you can test a compile, you can run test alone. All of that stuff works because both the declarative and programmable builds config files are in the same build hierarchy, in the same build tool. They form the same module tree and same task graph. So I have my programmable build file at the root of the module tree, which has its own compile and run and assembly tasks and so on. And as a submodule, build.test, which is declarative, which then has its compile, assembly, and test task and so on. So you can have different modules within the project using either declarative or programmable styles. So for maybe the most boilerplate modules that are all very similar, which most projects have many of them, you can use a declarative style. But for the some modules that are doing something special, some special code gen here or some special like post-processing of a compile output there, you can swap into the programmable style without having to like overhaul your entire code base and change to a different build tool. The other thing you can do is you can use custom module traits to in your declarative build files. So custom module traits like line count Scala module here are written in Scala, as we saw earlier. But you're not limited to only using them in your Scala programmable builds. You can also use them in your YAML declarative builds as such. So here I have line count Scala module in my programmable build file, and I can inherit it in my package.mil.yamls by saying extends rather than extending the built-in Scala module or extending the built-in Java module. I'm extending my own mil build line count Scala module. So I get all this stuff inherited. I can override things in the YAML as you'd expect. And this generates a build graph that has build with build.foo and build.bar, which both inherit from line count Scala module. And each has its own compile and whatever stuff, in addition to the new line count task that I'm adding in my line count Scala module. And I can then do mil show foo.line count, mil show bar.line count to make use of this inherited functionality. So basically, if you have a whole bunch of logic that you want to reuse within your code base, but the logic is kind of standardized, you're not forced to use programmable builds throughout your whole code base. You can just have one place where you define your module trait as a template, and then you can inherit it throughout your code base in the declarative build files, which kind of constrains you to using the standard way of doing things rather than having to copy paste or have the flexibility to maybe do something different and do something wrong. So that's the idea of integrating declarative and programmable builds. I think it's quite unique to Mill. Like most other build tools are one or the other. It's Gradle or Maven, it's Cargo or Bash or Make. But with Mill, you can kind of use both of them at the same time where they make sense and integrate them together quite nicely without having to have this huge like divide between the two strategies. So the way I think about when to use declarative builds is that declarative builds are simple, they're concise, they're also extremely limited and often cannot do what everyone needs to do all the time. Programmable builds are complicated and verbose, and which makes them kind of annoying to use for simple projects or simple use cases, but they're flexible so they can do what everyone needs to do, although perhaps maybe in a slightly more verbose way than the declarative builds can. So sometimes they are completely different tools. You have Cargo one side in Rust, and you want to use Cargo, and you have SBT on the other side in Scala. Sometimes they're different facets of the same tool. You have like pom.xml versus a Maven custom Mojo plugin. You have Gradle.properties versus build.Gradle. And with MIL, previous versions of MIL before the recent 1.1, you're limited to only being fully programmable, which is like one far end on the spectrum here, where you're using the most powerful, most flexible, but also the most complicated and verbose build syntax. And with MIL 1.1 and above, you now have ability to go anywhere on the spectrum. You can still use the programmable builds. You can use a declarative build or YAML files. You can use somewhere in between, as I showed earlier, mixing and matching them within the same code base. Or you could go all the way and just have a single file script with the YAML as a header comment. And that is your project as a single file that can easily email to someone, attach with issue tracker, submit a bug report, demonstrate the prototype, and so on. So that's the presentation. This is the last slide. So we talked about the MIL build tool, downsides of MIL's programmable build styles, the new declarative build styles, and how it also allows MIL Scala scripts, in addition to Kotlin scripts and Java scripts as well. And we talked about how integrating declarative and programmable builds gives you a lot more flexibility and freedom versus being locked into one style or the other, which is often the case in traditional build tools. So this is all available now in the latest versions of the MIL build tool. So if any of you want to try this out, maybe you prefer this kind of style for your project rather than having a full programmable build syntax, please try it out and let us know on the issue tracker or discussion board how it goes. Thank you. Jamie?
Yeah, so I wondered, is there like a fixed set of keys that you can, tasks that you're allowed to override, or can you override like custom tasks? For example, like core module dependencies on stringlet, or the references to other modules. So I guess that you have to special case that somehow, or it's just not allowed. How does that work?
Yeah, so I think there are basically two custom special keys in this. So if I go back here, so all the tasks that can be serialized to JSON can be overridden. So that means things like workers, which are in-memory things that can't be serialized, cannot be overridden. But all the things that can be serialized to JSON and get cached on disk can be overridden. And there are two magic keys, which one of which is extends up here, where extends, we need to do this Scala inheritance thing, and there's no easy way to do that without actually compiling the code. So we do use code generation, as you saw with the error message earlier. And the other one is the module depth, as you mentioned. So I don't know if I have an example in here. I don't have an example in here, but if you define module dependencies, those are also not tasks. So those are special case to resolve the module using that string, using MIL's resolve functionality. So those are the two special case things, and there's a few variants like compile module depths, runtime module depths. But then the rest of these are all just tasks. As long as they can be serialized, you can override them. Any other questions? The back?
Based on your previous talks, I thought the benefit of using MIL comparing to SBT, for example, is that it's easy to understand things because like it's a Scala code, right? You can just navigate into functions, see some documentation, and like you don't need to go critically in terms of SBT. But now you say that, okay, we have YAML, we have like all the configuration, but how is it different from SBT then? Like if I have a simple project, right? And if I only need like to just compile some modules with simple options, why would I use this YAML configuration instead of like a non-common tool like SBT?
Sure. So one big thing is performance. If I run a MIL command from the command line, it takes 0.1 seconds rather than 5-10 seconds that SBT would take, we saw earlier. I don't have time to sit and wait while it's initializing my MIL build. One area is many people don't like the SBT syntax. I don't know if everyone likes it, but I know many people don't like it. Not everyone likes YAML either, but I think a lot more people in the world globally know YAML than know SBT syntax. Like YAML has lots of problems, but it's generally quite well known. Your Kubernetes is YAML, your GitHub Action is YAML. You probably know YAML despite its problems. And we do manage to resolve many of the problems here. So things like your number parsing, your NO becoming Norway. We fix all of that. So we generally get most of YAML without its problems here. Yeah, I think that's basically like, if you like SBT, then it's fine, you can use SBT for simple things. If you think SBT is slow, if you think SBT syntax is weird, or you generally want something that's slightly more flexible, maybe as your program gets bigger, you want the performance to stay good, and you want to be able to customize things without having to change a whole different build tool to make it readable, Mill then lets you do that. Like, you can start off with the YAML syntax, which is great, and when your project grows, you can use the integrations between the declarative and programmable styles to get the more powerful stuff without having to change a different build tool. Versus what you'd say, you start off with a small SBT build, and oh no, it's become a big mess, I need to rewrite the whole thing in Mill, which then becomes quite a pain in the neck. Yeah. Over here?
So I want to follow up to this question. So as an end user for a meal, for example, when I'm using programmatic mode right now, I have full ID support. So I have completions, I can easily explore all possible keys. I don't know that, for example. I don't know meal in my memory. So I can just write fork, I will have completions and know what is available. In YAML, I don't have it. So why should I even consider doing this? If Scala is so simple, the build definitions in Scala and programmatic mode are also very simple. And this boilerplate that you are talking is, in my opinion, minimal. I don't see big benefits.
Yeah, I mean, if you think this looks good, then keep writing that. It's fine.
Yeah, but what about the ID support here? As an end user, I don't know Mill. I want to create some more complicated build, but still it does not require some custom hacks. So we don't need programmatic mode. How can I know that I need to write home settings or for arcs or resources? I would need to go to the documentation and manually visit it. It's a bit painful, I think.
Yeah, it's not as good. We haven't added support for this in IntelliJ yet. We would need to add custom support in IntelliJ and VS Code. We haven't done so. But yeah, I mean, as I said, if you think this looks better than this, then that's fine. We keep supporting it. Sorry?
LSPs for YAML exist. So you have go to definition and go to reference and everything works.
It does. What you need is something that goes from the YAML to the Scala code, which doesn't exist yet.
Okay.
Yeah. So we could add it. We haven't done it yet. We just released this last month. We haven't gone and patched IntelliJ and patched VS Code and patched NeoVim to add all this functionality. Like, yeah. But yeah, basically, I know a lot of you like Scala because that's why you're at Scala Meetup. If you think the Scala looks great, then that's fine. But I know a lot of people don't think this looks great, and a lot of people think this looks better. And there's no right answer here. There's no right or wrong. Some people like one, some people like the other. What Mill does is we provide both, and we provide both in a way that's reasonably well integrated, so you don't need to make a hard choice at the start of your project. If you decide you made a mistake, just change it the other halfway through, and it's easy to do so. Yeah?
Another question. So you said that we can start with YAML and then we can combine them together.
Yeah.
So did you consider creating a tool that allows us to migrate from YAML to programmatic build? So basically generate the Scala code out of your YAMLs?
Considered it, haven't actually done it. Yeah.
Okay.
Can probably be done because we already do that for the importer. For example, we import Maven builds and Gradle builds, SVT builds into Mill and generate that code for you. So we could do that for YAML, but we haven't done it yet. Yeah. Over here?
So I'm a lazy programmer and I don't like doing migrations.
Yeah.
So like considering Mill 2.0 or whatever, which config would you deem more stable? The Scala one or the YAML one?
I mean, the Scala config is definitely more stable given that it's 7 years old and the YAML config is 1 month old. So, I mean, Scala config has changed. Like the last breaking change to it was about a year ago. But I don't think the YAML is going to change very much because fundamentally the YAML reflects the Scala data model, as I said earlier. So like the whole data structure within Mill is quite hard-coded to a tree of modules with tasks, which each have a tree of JSON within it. So that's not really going to change probably. So the YAML syntax that reflects that probably isn't going to change. We may add more features, but we're probably not going to break stuff in the YAML either. I mean, I can't predict the future, but it seems unlikely that it's going to have much churn. Yeah. And again, it's just a JSON tree, right? So if you want to add a new JSON format, JSON5 format, TOML format in front of it, or DAL format, in the end, it's all just a JSON tree. As long as it combines the JSON, you can feed into Mill. So I wouldn't worry too much about like the breaking changes, given the simplicity of the underlying model. Yeah. Any other questions at the back?
Yeah, so a question. reversible for simpler things. And if I correctly understood from one of the slides, if something is missing, then I can embed this little programmatic snippet
Yep.
if needed. And for example, I would like to exclude source generated folder from test coverage, and maybe it's not covered
Yep.
with this declarative one. Then I can have it a little bit of.
That's right. That's based. For that you use custom module traits where you put whatever custom overrides or logic here, and then you just inherit it in all your YAML files. Yeah.
So I can have 90% of the declarative and few things.
That's right.
If needed.
Yeah. Okay, over here.
Sounds good. That means basically this traits with a custom code, it's something like alternative for the SBT plugin.
Yeah.
Or not. So basically, is it possible to write something like SBT plugin, which would be like auto-load plugin, which would provide some functionality or change the behavior of the build?
Yes, that's basically what these traits do. So they don't work quite the same as SPT plugins. SPT plugins have this global load resolve step thing that works kind of differently. Mail is just a trait that gets compiled and you use it as a JVM object, like Java-lang object with methods. But yeah, these are your plugins. You can have them locally, just in your code. You can publish them in Event Central, other people can use them. They behave as traits, and it turns out that traits with their mix-in style, multiple inheritance, and overrides and stackable traits basically gives you almost all the features you need from a plugin framework, but without having to reinvent it myself poorly. So SBT has its own custom plugin framework that looks very similar to traits with its own bugs and quirks and other stuff. And for Mill, we just use traits, and it more or less does what we need, like with override and super and multiple inheritance and so on. Yeah. Yeah, over here.
So, like, if you want to extend your build with some third-party mill mix-in trait that's on Make,
Yeah.
does that go in like the mill build directory, or can you include it inside one of these?
It goes in the root build file. So if it's a root build.mil programmable file, it's in the build header. If it's in the root build.mil.yaml file, it'll be in the mil-build subkey. This is in the documentation. So with documentation, you look for third-party, like using third-party libraries in your build, it'll be there. You don't need to memorize it. Yeah, so the mill build is built using mill itself, and the configuration for that, including third-party libraries, goes in these sections in the root build file. Yeah, over here.
I wanted to follow up on the ID integration as a developer here. So
yeah.
do I understand correctly that these YAML files are dynamic in nature, so there's like no schema, it's validated again. So it means that there's no autocomplete. I also wonder what happens when I make a typo? Do I get a reasonable error message, or
yeah,
a compilation error?
So let's try. I haven't actually tried this, like that mill compile all. So I've tried to add error messages to many common cases, including your Levenstein distance recommendations and everything. So this works if you do things sets, for example, like hello 1 2 3. You'll see there's nothing similar. Just says doesn't exist. The one place that you make a typo, you get bad errors, is in the extends clause, because as we saw earlier, that I mentioned earlier, this stuff gets code generated into Scala code because that's what we need to do. So unfortunately, you do not get good error messages in the extends clause. If you put in the wrong type, for example, I do Maven dependencies like hello. You do get some reasonable syntax or schema error. When you try to deserialize, it'll say that, hey, I expected to get a list here, or giving me a string. So yeah, I mean, as mentioned earlier, like you don't get jump to definition here the same way you get jump to definition in your Scala code, and that's a limitation that we need to fix. But I don't think it's a fundamental limitation, because unlike what you said, we actually do have schemas, because we do know all the types of all these keys. And as of the latest version, the JSON library, uPickle can generate JSON schemas for them. We just haven't wired it up to IntelliJ or VS Code yet, but we actually do have all the metadata available if we want to do something. Yeah, so that would maybe be a next interesting thing to do here.
So as long as I extend these built-in things like Scala module, there is like a well-known schema, unless I define my own traits, right?
Yeah, I mean, even if you define your own trait, your trait has a statically known schema, right? You compile it, the bytecode has these methods, and each method has a return type which has these fields. So we do know the schema of these things. We just haven't made use of it to add IntelliJ integration because all this is new. Yeah. Okay.
Not a question, but just a comment. So it looks like compared to what we have in SBT, this stuff is easily introspectable by third-party tools. So for instance, if you, first you need like some additional properties which are needed by the Jenkins job, like CI jobs, and you cannot put them in SBT files because like for Groovy code in Jenkins, it cannot easily read like Scala code.
Yeah.
This stuff can be read, so you can add like additional properties there which will be used by Jenkins, and like so everything will be in one place. It's really neat.
Yeah, at least right now it doesn't let you put additional stuff like it showed earlier. If I do like hello world, it will.
You can circumvent that.
Yeah, I can turn that. I can probably turn that off if you really care. If someone really cares about it. Right now,
you
just.
find like a dummy property in your like base.
Yeah. I mean, I guess traditionally the way you're intended to interact with these mil builds is by querying it, because, for example, I can do mil show maven deps, foo.maven deps, sorry, and you get the JSON out that you can easily parse and manage. So that's how you traditionally recommend you interact with mil, and it's fast enough that it doesn't become a pain, like it's like 0.1 seconds per query. But yeah, it's meant to be a lot more transparent in SBT. Once you put things in SBT, getting the data out takes 5 seconds because that's how long SBT takes to run. And even with the new client mode, it doesn't always quite work as well as you'd like. So this is meant to be very easy to read, very easy to write, and very easy to get the data out, both for the Scala code and the YAML code. Yeah. Cool. Any other questions? Going once, going twice, yeah?
What is so fundamentally different in Node that it's so much faster than SBT?
Very aggressive caching is one. We cache everything. So we cache a JVM, we start the process, we cache it. Yeah, the launcher is native at least, so the binary, that's I think 0.1 seconds rather than 0.5 seconds to boot up a JVM. But the background daemon, we cache a background daemon. When you compile Java code with a weird JVM, we'll cache that JVM as well, so you have a long-lived JVM that runs a special compiler for your Java 26 or something that's not the default. All your artifacts get cached, or cache disk as JSON. All the class loaders get cached, because class loader optimization is actually what takes a long time on the JVM. JVM starts up quickly, but optimizing the class loader contents is slow. So if you start up a class loader on a hot JVM, it still can be quite slow to warm up. So Mil caches all these things very aggressively, much more so than SBT does.
But on the other hand, can I easily edit this cache, for example, when working with snapshot release of some library, and if it's cached too much, I would have trouble because I would not be able to refresh that. So is it easy then also to get rid of this cache from that?
Yeah, you can just RM remove the out folder, or on the task by task level, you can remove the tasks out folder for ad hoc cleaning, and you can use a input task that doesn't get cached if you want that task not to be cached. So like source folder, the source code is an input task, for example. So every time you change the source folder, we'll reread it, and then you'll decide whether or not to do the downstream things. But whether or not you do downstream things, you'll always check the source folder because it's an input task. So you can use input task for your Git version commit, you can use input task for your snapshot dependencies. So those always get run, and only if they change will the downstream things start changing, invalidate. Yeah, I guess the other thing that I think Mil is a lot easier to make fast in SBT is that the data model is or execution model is a lot simpler. So Mil's initialization logic basically says, here's a bunch of Scala code with an object, like Scala singleton object, please instantiate it, and it instantiates object, and all the stuff that happens lazily in objects happens. SBT has this really complicated like phase loading with kind of a 4-dimensional matrix of tasks that then get loaded as one by one. So it's kind of like a inner platform, you know, like one is mill is just running on the JVM. JVM is pretty fast. And SBT has its own interpreter running on a JVM. SBT runs also an interpreter. And every time you add another layer, it gets 10 to 100x slower. So that's one of the reasons why SBT is so slow, in that it's basically re-implementing inheritance, re-implementing objects, re-implementing methods, re-implementing fields, re-implementing super and override and mutable state, all in user land in your Scala code. So setting a variable in SBT takes a lot longer than defining a method in mill, because setting a variable in SBT is a whole bunch of methods being called to do something, whereas in mill it's just a JVM method. So I think that's the other thing that makes mill a lot faster than SBT, even though conceptually they are quite similar in what they do.
Yeah, I think also when you first compile the build, whatever, it actually code generates everything and caches that also to the disk, like your class path and everything.
Yeah.
So that literally just immediately just loads from like reflection or something super fast.
Yeah, it basically caches everything as JVM objects, and like you know SBT has problems with like 200,000 tasks or 200,000 keys or whatever. But you think about it, you're running on a JVM, 200,000 objects is nothing. It's only when you have 200,000 objects, each surrounded by its own machinery, that becomes a problem. But in mill, it really is just 200,000 objects, and a JVM is no problem managing that scale of complexity internally. Any other questions? Yeah?
Just a question. So about declarative style, I think it's quite useful for other systems, maybe like Kotlin Java, because they don't need to dive to Scala. And I don't know any like cases when like Kotlin Java users switch to mill or Gradle.
I do know them, but they all switched before the declarative style, because the declarative style is pretty new. So they suffered the Scala syntax that they had to learn because they didn't know Scala, and, but they weren't happy with Gradle or Maven. So, and I know one company in Boston is currently porting their Java monolith to mill without the declarative stuff, just because they're finding Maven is too slow for a very large code base. Yeah. Yeah, we'll have to see that in 2026 if anyone swaps to a declarative style. Like, again, it's all new, so you won't see big users yet. Hopefully, we'll see them in future. But yeah, a big motivation is, like, if I'm a Java developer and I have a 10-file school project or 1-file school project, I don't want to have to go write like Java Scala code like this to go and configure my school project. I want to write Java code or Java build config that looks like this. And with the declarative style now you can. You just have extends Java module, Maven dependencies, and you're good to go. Or you can even use a single file script in Java. So earlier I showed you the single file script in Scala. So here's a single file script that does a Wikipedia traversal, article graph traversal using JSoup to parse the HTML. But you can also do the same thing in Kotlin, again using the same simple header syntax. Or in Java, slightly more verbose, but actually not that bad even now. Nowadays, Java, you have var, you have local type inference, you have many things that make Java less verbose than it used to be. So the hope is that these things will let people who are not Scala experts, who love Scala syntax, to let them also use mill, get all the performance benefits and stuff without having to go learn all the weird stuff about Scala defs and object package and other Scala things like that. Yeah. Cool. No more questions. I guess we are done. Thank you.
All right. Thank you very much for coming, but it's not the end of the night. Actually, it's just the beginning. Hopefully. Yeah. So you can still hang out here and finish whatever left there. Here's Przemysław. He will lead the first team going to the Deer Station pub. Actually, I know some people already sent me some pictures of Deer, so they are already there. Yeah, and yeah, enjoy the night. Remember that if you are able to make it to the keynote, it means that you wasted tonight's evening. So just keep that in mind. Keynote is for skipping, Yeah, thank you very much. Enjoy Scalar, enjoy the rest of the week, rest of the night. Thank you.
pasuje, potom si nejhrával.